Greetings, Year 11, and welcome to another exciting class dealing with quadratics. So today we're going to be talking about the discriminant. Let's get into it. Righto, first of all, we know the quadratic formula. Here is our quadratic formula. But what does the quadratic formula do? Well, the quadratic formula is used to find x-intercepts for any quadratic or parabola. And it's normally written in this form here, so we can get our values of a, b, and c to plug into the formula. And you can see on the diagram the quadratic formula would find on any parabola where the parabola crosses the x-axis. Now, the discriminant, when you look at your quadratic formula, the formula here, the discriminant is the part underneath the square root sign. Now, that's going to be very, very powerful and very useful for dealing with questions down the track. So when we're writing the word discriminant, it's quite a lengthy word to write, we abbreviate it using a triangle. And that triangle is pronounced discriminant when we see it written, especially when it's linked to b squared minus 4ac, because the discriminant is the bit under the square root sign, which is b squared minus 4ac. Now let's actually talk about what actually happens. If the discriminant gives an answer that's less than 0, that means it's negative if it's less than 0. So if the discriminant is a negative number, let's come back up to our quadratic formula. If the bit under the square root sign is a negative number, we can't take the square root of a negative number. It gives us no solution. So we say if the bit under the square root sign is negative, there's no x-intercepts. There are no solutions. Also, when we're looking at the quadratic, and remember the quadratic is just going to be written like this, it's going to be something like y equals ax squared plus bx plus c. If the number in front of x squared is positive, we know that the parabola opens upwards. If the discriminant is less than 0, we know it doesn't touch the x-axis. So any parabola that opens upwards and doesn't touch the x-axis has a special name, and it's called positive definite. And if the discriminant's negative, but the value of a in front of x squared is also negative, it means the parabola opens downwards and it doesn't touch the x-axis, so that's the example of a parabola that is negative definite. Now, if the discriminant equals 0, so let's come back to the quadratic formula. We're using the quadratic formula and we get underneath the square root sign 0. What's the square root of 0? 0. So when we're doing the formula, we go minus b plus 0 and minus b minus 0. You're going to get the same answer. And so if the discriminant's equal to 0, there's only one answer. It's called a repeated answer. Now let's look at what happens if the discriminant's positive. If that's what it says there. If the discriminant is greater than 0, that means the discriminant's positive. If the discriminant's positive, you get minus b plus the square root of a positive number and minus b minus the square root of a positive number. You're going to get two different answers. But if the discriminant is a perfect square, that means we can take the square root of it. For example, 9, and the square root of 9 is 3. 16, the square root of 16 is 4, and so on. So if the discriminant's positive, and it's also a perfect square, we can say there are two answers and they are rational. That means they can be written in fraction form. However, if the discriminant's positive, but it's not a perfect square, let's say I get the square root of 2. You can't do the square root of 2, it's just a messy decimal. There's two answers, but they would be called irrational because you still have surds involved. Now that's a lot of theory. Let's actually try doing it. First question, use the quadratic formula to find how many real roots each quadratic equation has. Well, here's our quadratic equation. I've put a 1 in front of the x squared so we can see that a is 1, b is 3, c is minus 7. We're going to use the quadratic formula, and wherever we see a, b, and c, we put those values in. We follow it through, and we end up with exact answers in surd form, or we can actually give the answers in decimal form. This is correct to 2 decimal places. I've rounded it. But the question says, use the quadratic formula to find how many real roots there are. Well, there are 2 answers for this one, so there are 2 real roots. There are 2 x-intercepts. Part B. Well, let's get our value of A, B, and C again. Got to be careful with this one because B is negative. So we use our quadratic formula. Notice B has to be squared, so keep the brackets. It's -1 squared. And out the front it's -1. So when you plug those values in, you end up with this. And this, if you just put that straight into your calculator as it's written there, it'll give you math error. And the reason it's giving you math error is the discriminant, the part under the square root sign, ends up equaling -11. And we can't take the square root of -11. So there's no solution, which means there are no x-intercepts or no roots. Let's go to part C. Use the quadratic formula again. Careful because B is negative. So we plug in our values into the quadratic formula. And in this case, if you plug that into your calculator using the plus case and the minus case, you're going to get the same answer. And the reason you get the same answer is because the bit under the square root sign is 0. You end up with 6 plus 0 over 2 and 6 minus 0 over 2. So you just end up with 3 in both cases, and we don't need to write it down twice. We just say there is 1 x-intercept. It's called a repeated root because 3 happens twice, but if you just wrote x equals 3 and you didn't write the second 3, that's fine. Well, in example 1, we used the quadratic formula. Now in example 2, it just says show that this equation has no real roots. It does not say find what they are. So you could use the quadratic formula and try and find them, but we're going to use something a little bit faster. Now we know the discriminant's b squared minus 4ac. Let's just find out what the discriminant is. So I know that a is 3, b is -2, and c is 5. Let's put them into the formula for the discriminant, and it works out the discriminant's -56. Remember, the discriminant is the bit under the square root sign, and you can't take the square root of -56. So that's nonsense. Because the discriminant is -56, we can say because the discriminant's negative, there's no real roots. Example 3, a little bit more challenging. It says find the values of k for which the quadratic equation there has real roots. Now, when do real roots actually exist? Well, they'll exist if the discriminant's positive. They'll exist if the discriminant's equal to 0. Real roots will not exist. There'll be no roots if the discriminant is less than 0, if it's negative. So real roots exist when the discriminant is either positive or equal to 0. Well, that means b squared minus 4ac must be positive or less or equal to 0. Well, what's a? A is the number in front of x squared, so a is 2. B is the number in front of x, it's -4. And c is the constant term, it's k. So we put those values into the formula, and we end up with 16 minus 8k is greater than or equal to 0. Take 16 to both sides. Now I'm going to divide both sides by -8. Dividing by negative is going to reverse my sign, and there is my solution. If k is any number smaller than or equal to 2, this quadratic will have real roots. If it is a number that's bigger than 2, it's going to have no solution. It won't have any real roots. Let's look at example 4. Show this quadratic is greater than 0. It means it's positive for all values of x. Well, let's actually have a look at this. Let's look at the discriminant. If we look at the discriminant and we know a is 1, b is -2, and c is 6, we end up with a discriminant of -20. Now, what does the discriminant of -20 mean? Well, it means that you can't take the square root of a negative number. It means there are no solutions. So if I tried to graph y equals x squared, take 2x plus 6, there are no x-intercepts, which means it's either always above or always below the x-axis. The only cases I've got is something like this or something like this. So what is it going to be? Well, let's look at the number in front of x squared. It's a 1. So because the discriminant's negative, we know there's no x-intercepts. Because the number in front of x squared is the number 1, which is positive, then the parabola must open upwards. It's called concave up, which means that x squared take 2x plus 6 is greater than 0 for all values of x, because that statement means show the parabola is always above the x-axis. So the parabola must always be above the x-axis. If it's opening upwards and doesn't come in contact with the x-axis, there's our solution. It's also a case because it opens upwards, so this is my rough sketch, I have no idea where it is, but it opens upwards and it doesn't come in contact with the x-axis. It's called positive definite. Let's look at example 5. Let's show that the line 6x plus y plus 9 is a tangent to the parabola y equals x squared. Well, let's actually deal with what we've got to do in this question. It says to find where the line and a parabola meet, we've got to solve it simultaneously. So if I solve this line and this parabola simultaneously and I find they only meet once, then it's a tangent. If this line touches a parabola twice, it's not a tangent. If it doesn't touch it, it's not a tangent. So let's substitute y equals x squared into the line. So everywhere I see a y, I'm going to replace it with x squared. So I'll put an x squared there, which gives me x squared plus 6x plus 9. Now, I could solve it, and I actually prefer to solve it, but this question just wants me to, I'm practicing using the discriminant. If I look at the discriminant, I know a is 1, b is 6, c is 9. Using the discriminant, I end up with a discriminant of 0. And what does a discriminant of 0 mean? It means there's only one answer. So this line and this parabola will only meet once. And if they only meet once, that line must be a tangent. So because the discriminant equals 0, there's only one solution, which means the line touches a parabola once, making it a tangent. I didn't actually find the point where they touch. I wasn't asked to. It just says, show it's a tangent. So it's a bit faster doing it this way. Let's have a look at example 6. Let's use a discriminant to determine whether the following equations have got 2 rational or irrational solutions, or one solution or no solution. So let's look at the discriminant. We know a is 1, b is minus 9, c is minus 10. We use our formula and we get a discriminant of 121. Now because it's positive, I know there's 2 answers. Can you take the square root of 121? Yes, you can. So we can actually say because the discriminant's positive and because 121 is a perfect square, there are 2 rational solutions. Let's look at our next one. We're just going to study the discriminant. We know a is 1, b is minus 2, c is minus 14. And when I plug those values in, the discriminant's 60. Now the discriminant's positive, which means there are 2 answers. But can you do the square root of 60? No, you can't. So there are going to be 2 answers, but 60 is not a perfect square, so there are 2 answers and they are 2 irrational answers. So in both cases, we've got 2 answers, rational in part A, irrational in part B. Let's look at part C. We're going to study the discriminant again. We know a is 1, b is minus 2, c is 14. Plug those values in and I get a discriminant as minus 52. Now can you take the square root of a negative number? No. That means there are 0 solutions because the discriminant's negative. Let's look at the last one. Now I can't do this unless it says equals 0, so I've got a plus 49 to both sides first. Now I want to study the discriminant again. A is 1, b is 14, c is 49. Plug those values in and I get a discriminant of 0. And if the discriminant is 0, I know I get 1 rational solution. or one answer. So, time for you to try doing some questions. Enjoy the magnificent experience that is maths. Bye for now.